it's my pleasure to introduce to you Fermín Moscoso del Prado Martín, our speaker of today. And Fermín is a, excuse me, Fermín is the lead scientist at Linguist Technologies, a company that is, I hear, based in Estonia, but has representation internationally. And in this capacity, Fermín is working on vocabulary learning, automatic construction of language course materials, data analysis, and I'm sure we'll hear a lot about that, and I'm personally very excited about this talk. Before Fermín started his work in the industry, which I think was about 3 years ago, he had a master's in engineering, specializing in artificial intelligence, and PhD in linguistics, or computational psycholinguistics, really, from Radboud University, working with Harald Bein, whom many of you know as a presenter at conferences and so on. So Fermín since then had postdoctoral training in cognitive neuroscience and was faculty at the University of California, Santa Barbara. And academically speaking, he's as close as it gets to the faculty that is represented here. We share many interests in, be that in morphology, information theory, lexical processing. Many of us have co-published with Fermín. Many of us have heard him give talks at the conferences, and Fermín has always contributed to the Mental X conference. So what makes this event all the more exciting is that Fermín knows very well both sides of the coin. He knows exactly what we are trained on. He knows exactly what we're training our students on, and he knows which of these skills and how they are of use in the industry. So the floor is yours, Fermín. Thank you for sharing your expertise with us.
Thank you very much, Victor. Thank you for inviting me. It really is a pleasure to talk back to academia again. I mean, I've been, as Victor mentioned, I've been out of academia for almost 3 years now. And I really enjoy being able to talk to students. I'm just going to give a few notes. I hope that what I say is not too trivial. So, and please feel free to interrupt me at any point and ask further questions. I'm happy to give more details about things that I mentioned or things or anything that comes to your mind that I think I might have something to say about. I would recommend that if there are things that are directly related to what I'm talking to at the moment, you interrupt me and ask. If there are additional things that I haven't talked about and you wish me to say something about, I would keep those to the end, just to keep a little bit the structure of the talk. Now, I'm going to try to switch to sharing my screen and prepare just very few slides with some guiding notes. I might have some trouble in sharing my screen since I'm a computer scientist. I'm not very good at using computers. So let me try to do this. Okay, share screen. And now share, but then I have to go. Sorry about this, and as I told you, I'm clumsy at this. Here. Can the slides, well, the proto slides be seen properly?
Yes, very well.
Yeah.
Oh, great. So, these slides are very basic, very simple. They just have some notes and some names of things that I have found important in my transition from academia into industry. The first thing, so I'm going to give you a little overview of what I'm going to talk about. First, I'm going to tell you about my own career path, what I did and how I ended up switching to industry and how did that process go. Then I'll give you a very short overview of the types of jobs that there are in industry. One thing that I found when I was trying to move into industry myself is that I saw the job ads and I didn't really know what they meant. I didn't know to which kind of jobs I should apply and to which kind of jobs I should not even bother. And then at the end of the talk, I will be focusing a little bit on the kind of skills that you need to have to join this particular industry. And I want to be very clear. This is not, I will not be talking about joining industry in general. So one thing that I really want to stress is, this is something that I learned from my own experience when I was leaving academia. When I began thinking about it, it took me, I was considering, pondering the fact of moving out of academia for 2 or 3 years, kind of secretly in my mind. But I was very scared of it because I thought I had nothing to contribute. And there was nothing I could do outside academia. And I was obviously wrong. Now, the skills I'm going to talk about are very specific to those of you who consider going into the data science field. But there is many other jobs that people can do in academia and that people can do outside academia with the skills you have been trained on as grad students in psychology or linguistics. And I know several people who actually have done such transitions. So having said this, I'll start with kind of a brief CV or a brief commented CV. So I was originally trained as a computer scientist, but I was training as a computer scientist in the very old days. So I finished my degree in 1998. Which means that my computer science skills are clearly, or at least as they were taught to me during my studies, are by now extremely antiquated. And the tools I was taught to use, etc., are mostly not in use any longer, at least in this business. What computer science did give me, though, is I got extensive training in math, which I used throughout my career and also in my industry career. But apart from the math I learned in my undergrad, most of the computer science I learned is by now useless. So after my studies, I spent some time teaching in Latin America, teaching computer science. And then I ended up doing a PhD in psycholinguistics in the Max Planck Institute in Nijmegen with Harald Bayen, as Victor said. And this was a great opportunity for me, first because Harald was, and still is, an amazing teacher. He was also Victor's own supervisor. And during my time in my PhD, I learned obviously a lot about linguistics, which I didn't know, although I had been reading linguistics by myself for a couple of years before I started my PhD. So I was not completely ignorant of linguistics. But I did learn a lot of statistics, which is what happens when you study with Harald. And I got really passionate about statistics, which is something that has served me very well, both in academia and in industry ever since. And at that time, I was very interested in the field of neural networks, which by then were a kind of small academic field or subfield with not much use in industry. This has changed dramatically since then. Then, after I finished my PhD, at that time, neuroimaging was growing bigger and bigger and was very much on hype. And the hype I don't think has gone away since then. And I had really no knowledge about the brain. So this was my big priority. I wanted to learn about brains, and I was lucky to land a postdoc on neuroscience of language, which was a kind of funny postdoc because I actually started being a postdoc without having the slightest idea about neuroscience, apart from basic popular knowledge. And it was a bit ridiculous at some points, at least in the initial part, because I found myself in an office with 3 other postdocs who were actually very good neuroscientists, asking all kinds of stupid questions about where different parts of the brain are. So I could actually understand the papers I was reading. But I did learn something, I did learn a lot. And finally, I got a Marie Curie fellowship to stay there, working more on my own and working more on the computational modeling part, which is what I was really good at. From there, I applied for a research job in France, in the CNRS, the Centre National de la Recherche Scientifique. Those are the French tenured academic jobs for scientists. And I was hired jointly between 3 sections, the computer science section, the linguistics section, and the psychology and neuroscience section. And I was working in between 2 labs, the dynamics of language lab in Lyon and the cognitive psychology lab in Marseille for 5 to 6 years. But during my time in France, well, the salaries in France in the research scientists in the CNRS are not that good. And if you are living by yourself and not with 2 salaries in a family, you end up living very tight. And at that point, the possibility came up to teach linguistics at UCSB in Santa Barbara, where Stefan Gries, who's here, is currently still is. So I moved to the US and I spent 6 years as a professor of, as an assistant professor of linguistics. And during that time, how to put it? Let's say I got a bit frustrated by different reasons. So I was, for many reasons, not very happy and perhaps not a very good fit to my own department. So, I mean, there were great people there like Stefan Gries, but there were other people I didn't get along with, and that became difficult at the point. And at the same time, well, there were several family events that happened that made me want to move back to Europe as soon as I could, in particular to Spain. So my father died at that time, and I needed to be closer to my mother so that I could be of help if necessary. And being in California, flying back to Spain is not that agile. But the academic situation in Europe was not that good in terms of finding jobs, and that was not realistic. And at the same time, I had been growing curious in the last years, seeing that a lot of research had shifted from academia into industry. So during the last, as many of you know, during the last 10, 15 years, there has been an explosion of work in machine learning and in computational linguistics in industry. And I remember in 2016 going to the annual meeting of the ACL, the Association for Computational Linguistics, and I was shocked that 90% of the presentations in the conference were actually given by people in industry, not in academia, which was rare for a scientific conference. And that made me think that, well, there were possibilities of doing things in academia, outside academia. And in particular, I'm a very data-oriented person. This could give me the opportunity of dealing with much bigger data sets than I could ever dream to have in academia. So I began considering it, but I didn't know where to start. I was completely lost. What kind of jobs? Where could I ask for a job? Where do I look for the jobs? What kind of CV do I need to make? I had no idea about all of that. And as I'll mention afterwards, what I started doing is I knew several people that have made a move from academia into industry, in particular to the data science industry. And I started literally calling all of them and talking to them to get some help and get some clarity on what are the different jobs, how did you go about, how do you write a CV, what do you do with your LinkedIn, etc. And I was very lucky because just at that point, Telefónica, which is the major Spanish telco and a big multinational, was starting what they call the Moonshot Factory, which was called Alpha, which was an ideal match. These guys wanted to do a long-range research into things that could be turned into very valuable products in the mid-term or long-term. So they wanted to start an artificial intelligence group there, and I was hired together with several other people coming to academia. In particular, 2 of us were charged with actually creating an artificial intelligence group there, focused on 3 things. One was what they call empathic AI, which in our terms is just recognition of emotions in both language, but also in faces, as well as explainable AI, which is a field in which what we do is try to break open the black box of the machine learning models. If you think about most machine learning nowadays in industries done using models that are completely opaque. And if these models are going to be used to take decisions that affect people's lives and that have health consequences and legal consequences and dire economic consequences, it's important to be able to explain what leads you to take a particular decision. So in order to do that, you have to, even if you use a very deep neural network model that is very opaque, you have to find some way of explaining how you come to that decision. And finally, a third area in which we worked was privacy-preserving AI. So privacy-preserving AI basically is machine learning with learning from data without actually seeing those data. So much of the data we want to learn from, we're working in the domain of health, and these are very private data from users. So we're trying to develop ways in which a machine learning model could learn from data that are encoded without actually decoding the data. This is what's called homomorphic encoding, if you look for it. Now, in Alpha, I initially were 2 people directing the team. So I was directing the empathic processing subgroup, and each of the other subgroups had 1 lead, and then 2 of us acted as leads of the whole team. I ended up being promoted to directing the whole team, so that's the 3 subgroups, and that put me a bit out of the actual research and doing much more management and leading with the and linking with the leadership and external partners work. And while I was at Alpha, by a very lucky coincidence, so the CEO of Linguist, Mike Mintel, who's a very interesting guy. Linguist is an application that is, many of you will be familiar with Duolingo. So Linguist is in a way a competitor. So we are trying to teach languages. In particular, we're teaching vocabulary, not much more than that. And the CEO wanted to use proper scientific tools for teaching language and for evaluating whether people are learning languages. And in order to do that, he started asking people in the field. He had already a very good scientist on board, which is Pavel Mandera, that some of you will know because he's also taking part in the activities of the Mental Lexicon as a grad student. And Pavel made him a list of people he thought he could talk to recommend possible younger hires. So Mike contacted me, I talked to him, and I really like his attitude and that he really had the intention of putting actual science behind it, not just making money, but making sure that languages were being taught. So I told him, look, it's a pity you guys are in Tallinn in Estonia because I'm not thinking of moving out of Spain, but otherwise I would take that job instead of recommending you somebody. And he said, well, in fact, my chief technical officer lives in Malaga. So if you want to work for us, you could work from wherever you want. And I've been working with them ever since. Now, I'm very happy in my current job, but there are some downsides as well. We can talk about it later. But one of the things that, at least in my case, I always consider myself like my major interest was knowing things. One of the caveats of working in industry is that even if you are in a very research-oriented field, and I am in my current job is such a very research-oriented field, you still have to focus on products, and you still have to have your main focus not in understanding things, but in getting things that work and that can be delivered. This can sometimes be frustrating if, in many ways, and make you miss academia, at least in my case. So, although I'm happy where I am, sometimes I do miss academia, I must say this. So, as I was telling you, I've always liked to define myself as a scientific tourist. Saying I started as a computer scientist, but then I kept jumping around to learn linguistics before my PhD and during my PhD, then some experimental and quantitative psychology, and I even got interested in vision. Then I wanted to learn about brains. Then I wanted to learn about physics and many other things. The nice thing when I was working in academia is that I was whatever I wanted to learn, I just went on and tried to learn it. I had the time to do that. Then when I needed to return to Spain, and I found that the better option would be to work in industry, given the situation for finding academic jobs that are decently paid in Spain. And I was totally lost. I was like, okay, well, I know a lot of useless stuff, or at least stuff that they consider useless, that I'm not sure many companies can really need. And yes, I'm good at programming, but I've never done it at an industrial scale, so I can certainly not be a programmer or a software engineer. And I don't know what to do. And the best thing I could do at that time was, well, the first thing is, well, I asked for help. So fortunately, I mean, you guys are grad students, many of you, and in conferences and throughout your career, you'll meet a lot of people, and you'll notice that many of them will end up moving into an industry. In particular, in my area, which was psycholinguistics with a very statistical and very computational orientation, many people I knew had already made the move. And what I started doing is literally calling them and asking them. And the thing that's very important to know is that people are extremely helpful. And what do they help me with? They gave me a little overview of what types of jobs there are, what kind of salaries to expect in different countries. But most importantly, they helped me rewrite my CV. So many of them share their actual CV with me. I say this because CVs in academia are very different from CVs in industry. The things you want to highlight in one or the other are totally different. Typically, the industry CVs are much shorter. So I now managed to reduce mine to 2 pages. And you need to stress totally different things and phrase things sometimes completely different. Also very important, at least in my case, and I know it's the case with many other academics, I didn't even have a LinkedIn profile. And everyone I talked to insisted that this was absolutely crucial in order to join industry and to be visible in industry and to be even considered for jobs. So I had to create from scratch a LinkedIn profile. And what I did was a lot of copy pasting from friends to start with, and then started adapting it. So the lesson here, most important lesson, is that people are extremely happy to help. People who have already made the transition from industry from academia into industry are very helpful. Even people that you don't know so well, that you wouldn't consider friends of yours, but just acquaintances whom you've talked to in a conference, will be happy to talk to you and set up a Skype call and discuss what you can do with what you are doing. So do feel free to ask people, and do it. If you want to ask me, feel free to do so. I'll be happy, and several people have done so since I left academia. Now, one thing that's kind of slightly embarrassing, is that when you create your LinkedIn profile, you'll have to list different skills in there. And typically, in order for people to believe that you actually have those skills, they want you to be endorsed by other people. Endorsed is other people who are able to click there and say, yes, I agree that Fermín knows programming in Python, for instance. Now, I was very shy about this, and several friends of mine encouraged me, so I ended up doing it, sending a large mass email to several contacts on LinkedIn, asking them to endorse me on things. And they happily did. This was also important for landing my first job. So in total, I spent, since the moment I decided solid that I wanted to leave academia, which was in December, to the point that I actually left, which was at the end of the academic year in June, I spent 6 months preparing CVs, talking to people, and getting things in place so I could actually be eligible for a job. And I was lucky enough that I could do the transition directly, leaving my job at UC Santa Barbara, and starting directly as officially a senior scientist in Alpha. Now, very important, apart from the technical skills, there is a ton of, quote, soft skills that many of you have. And those soft skills include public speaking, perhaps teaching, writing, managing people. Those things might seem very trivial for you, but they are not trivial in industry. So people give a lot of value to those. And this is more a note to the faculty among you. If some kind of explicit training can be given to grad students in these things, could be really useful in case they ever wanted to transition to industry. Specifically, some courses on how to manage people and some courses on public speaking or some form of training. Now, the next thing I found is there were many types of jobs, and I've only put here basically 3 streams, but these jobs come under many, many different names. So the 3 streams I'm mentioning here in the data science world are, on the one hand, you have what you would call the data scientist stream. On the other hand, you have what you call the data engineers stream. And the other hand, which is rarer, you would have what you would call the researcher stream. I'll talk first about the two first lines, and then a bit more, a little bit about the third one, although the third one is rarer to get, not impossible though. So most of the jobs are talking about either data scientists or data engineers, and I had no idea of what the difference is, or are they two names for the same thing, or they're actually different things. And in fact, they're actually different things. And this is something I really didn't know. So a data scientist is somebody who actually is given a problem or a question and some source of data, or will have to look for the data, and will do the data analysis, say, as if you are doing experiments in academia, what you would do in academia with your experiments, analyze them, take conclusions, and answer the question and give pretty presentations to stakeholders. That the stakeholders might be clients, but they might be also the leadership in your company, explaining what those data mean, what you have learned from the data. On the other hand, there is the data engineers, which is a completely different species. They're also well know a lot about statistics and about machine learning, but their job is not so much to solve the statistical problem or to do the analysis, but to deploy that analysis on a large scale. So typically, in many situations, you'll have tools that are repeating that analysis over and over again with things like Tableau. And the data engineer is the person that makes sure that the analysis is working smoothly from the technical perspective. So if you need to access very large databases, or have strong parallel processing, or be serving a lot of clients, the data engineer is kind of the hybrid between a software engineer and a data scientist. It's very important to know that data scientists and data engineers are not necessarily subordinate to each other. They are colleagues on the same rank. So you might have a data scientist who does the big analysis and has to present it to people and show how to visualize it. And you'll have a data engineer who actually implements those analyses on a large scale. And perhaps he's not the face showing it to the public, but it's equally valuable and equally paid, sometimes even better paid, in fact. Finally, the third stream, the researcher stream, I say it's rarer because only a couple of companies have that stream really. Sometimes some companies in some job apps say they need a researcher and what they want is a data scientist or a data engineer. Very often what they want is a data engineer, in fact. But some of the major companies, say Google, Apple, and a few others, do have a research and development department where people are actually doing research and publishing papers and going to conferences. And typically, they also have the junior, main, senior distinction. Now, in my own case, when I began understanding the structure, I realized that the places where I wanted to be was either as a data scientist or as a researcher. Clearly, data engineering was not for me. As I said initially, I was trained as a computer scientist, but my computer science skills were outdated, and those that were not really outdated were kind of rusty. So I didn't find it attractive to optimize the efficiency of algorithms or optimize the access to databases. Typically, these data engineer positions go to people with very strong technical backgrounds, most likely people coming from computer engineering. However, I know at least 3 people that are coming with backgrounds in psychology and linguistics that have gone into that direction because they love that, and they are very good at that, and they have taught themselves that. In my case, however, I was more interested in actually thinking on how to do the analysis, how to solve the problem, and how to explain and present the results. So the data scientist was a good match. And if possible, if I could be actually doing science, that would be ideal. So that's why I joined Alpha, although at the end it turned to be a slight disappointment in that sense. Now, what level should you apply for? So what I have found is that most data scientists and data engineers in industry, and even many of the researchers, are actually people not having PhDs. So these are people who are very often coming directly from their university degree, typically BSc or an MSc, and joining the company. Those people with an MSc typically join at the middle level. Now, with a PhD, if you play it well, very often you can enter directly at the senior level. What I would recommend for you, depending on how much experience you have and the depth of your technical skills, is that you do not apply for the junior positions. So the junior positions are typically for people that have at most a BA or a BSc and need a lot of experience into being guided into it. Now, in terms of what you will do, the job is very much the same between a junior and a middle data scientist. You'll be analyzing data, you'll be taking conclusions, you'll be presenting the results. If you're a senior data scientist, sometimes, but not always, you will also have to manage some of the people. By managing them, meaning like leading a larger project with 2 or 3 other data scientists or junior data scientists, but still you will do a lot of hands-on work. So you will still analyze data, and you still log into R and Python, etc. Then, if you notice, I've merged the 3 streams into a lead, and the lead is sometimes called a lead data scientist or a lead data engineer, but typically a lead has a team. The team can go from anywhere between 4 and 12, 15 people. And the team that a lead data scientist has or a lead data engineer has is typically a mixed team that will have some data scientists, some senior data scientists, some junior data scientists, but also some engineers, and perhaps even some graphic designers and things like that. In my team in Alpha, we had some data engineers, some data scientists, and then we had what we call the creative technologist, which is a cross between a programmer and a graphic designer. Now, apart from the type of job, it's very, very important that I have learned more by experience. So my first job in Alpha was basically a big multinational, Telefónica, and my current job is a startup. And what I've noticed is that the type of company is a very, very, very important thing, and it leads to completely different jobs, basically. On the one hand, if you're in a corporation, a large corporation that's already established, even the most innovative ones, say Google or Amazon or Apple, tend to be relatively slow-paced, which is nice because you can work calmly on a project and do things step by step and make sure things are right. But they can also be enormously bureaucratic in the sense that in order to start anything, you might have to go through many, many levels of the company. And in order to pay for a tiny piece of equipment, the bureaucracy might be enormous. That was the case in Telefónica, for instance. And sometimes it can be frustrating. You might spend a long time working on something, and then the direction changes and completely changes the priorities, and that ends up being wasted work. Usually, the corporate jobs pay better than the startups. Although this is not a hard rule. I know startups that pay really, really well. Now, the startup is a bit of the opposite. They're extremely fast-paced and lively. Typically, they have very, very young people. I think I'm probably one of the oldest in Linguist. In Linguist, we're about 40 people. But it can also be very stressful. So the rhythm at which you have to deliver products and improvements in the product, it's typically weekly or bi-weekly. This is nice in the sense that you get to see the things that you work on implemented and working very, very fast, and it's very rewarding. But at least for me, can also be extremely stressful and may force you to do things less well than you'd like to do them. And I particularly don't like that. Often, but as I say, not always, startups pay a bit less, but very often you also get stock options. And being a startup is a bit of a bet in that sense. Most startups end up failing, you should know that. But if you happen to be in a startup that doesn't end up failing, you might make a lot of money through those stock options. So there is a little bit of betting here, 2 different styles of work. The ideal would be something in between the startup and the corporate, with a not so extremely fast-paced work, so you can do longer-term things. Startups typically don't have the money to do very long-term projects because they might not exist in 2 years. So for instance, in my current company, we literally are raising money on a yearly basis. Now we're on benefits, but before that, we've been basically burning startup capital for several years. So you can never, you really need to focus on the immediate and focus on things that can actually give revenue to the company. Now,
I have a question.
yes.
On 2 slides back, you talked about data scientists, data engineers, and researchers. My question is what would be the most important skill for each type of job? From my understanding, data science would be, you'd have a lot of knowledge in just stats in general. Data engineering would be more R-based and Python, and then researchers would just have an inquisitive mind. What would you just say would be the most important quality for each of the jobs?
I mean, both data scientists and data engineers will have to be very good programmers. But there is different ways of being very good programmers. One way is like, well, you work in your own script in a very organized, not necessarily extremely organized. You are not so worried about the optimization, the deep technological aspect of it. You're really focusing on the statistics. You're focusing on the statistics or on the actual machine learning and on the conceptual part of the question. So it's like, okay, we have this particular question. How am I going to solve it, or how am I going to answer it? Well, I would do this, followed by this, then you get the results. You start plotting graphs, you decide which graphs are going to be plotted, and you explain the implications of this to whomever is involved, be the client or the upper direction of the company. On the other hand, the data engineer needs to be much more tech savvy. So their job involves much less communication towards the outside or inside, but making sure that those algorithms that the data scientist has been thinking about are implemented and they work extremely fast and efficiently and safely. So typically you have to go much deeper into the tech stack. So people who really like to pay a lot of attention to detail and to play a lot with computers and deal with the really low level details are the ideal people for data engineers. Does this answer your question?
Yes, it does.
Okay, so I'll continue. Now, what kind of technical skills are being asked? Now, before I go into the technical skills, I want to make just a mention. Now, the demand for data scientists at this moment is enormous. So companies are fighting to get, and they're getting very, very, very young people, very junior people, and even a very basic expertise, in many cases, is considered good enough, and they'll teach you on the job. Maybe they give you a more junior job, but if they see that you're able to learn, that will be valued. So you don't have to know everything. You can very, very openly in an interview say, look, I don't know this. I know it exists. You should at least know what is around there. That is important. I know it exists, but I feel capable of learning, and you can even argue, why do you feel capable of learning? And they'll very often take you. So, but the most basic things that you need to have there is have some programming and probably extensive experience in programming, at least in Python, and sometimes also in R. This is really a must. This is the very basic. If you cannot program at all, it's very difficult that you're going to learn any sort of data science job. So and more to the teacher side of the audience, it's important that grad students, if they don't have it before, have some explicit training in programming. They don't need to be a master of many languages. Just knowing Python should be enough, or sometimes just knowing R should be enough. Although if I had to recommend one of the two more used in the industry, it is Python. Although it depends on the type of job. There is some jobs for which people use more R. Now, the part that has surprised me more is the statistics part. So you need to know statistics, but they are remarkably simple. So for most jobs, apart from the machine learning, the only statistics that typically are going to be required from you are some form of dimensionality reduction, something like PCA and things like that, and the very, very base two-way experiments. which in the industry is referred to as A/B testing, and is listed as a skill in LinkedIn. So if you go to somebody's profile in LinkedIn and they tell you that they know how to do A/B testing, what they are doing is two-way experiments and typically an analysis of variance, not much more than that. With this, I want to highlight that even things that you consider very trivial are things that you need to list in your profile. And statistics in particular, they don't go much farther than that. They do go a lot nowadays through machine learning. And at least if you do a programming course, and that programming course includes some basic familiarity with basic classification and regression algorithms, and specifically dealing with concepts like variance, bias, and how to evaluate the results, this is very important. In using one or two packages, the most basic would be scikit-learn. That's really easy to use. Would be a really, really valuable thing. Now, these are the basic skills. What more advanced technical skills? Oh, I forgot one basic skill here. I now realize. Where was I? Here. One thing I haven't mentioned here, but it's also crucial. You also need to have some knowledge of databases. And by knowledge of databases, I don't mean that you have to be a database expert, but at least you have to be able to write some basic queries in SQL. This is really crucial because in any company that you go to, the data is going to be stored in some kind of database, and you'll have to access those databases to get the data. You cannot get somebody to access the data for you all the time and then you do your analysis. You'll have to do that yourself very often. So if you don't know the basics of dealing with a database, it's very unlikely you will be hired. Now, typically, I would say some knowledge of SQL queries would be good. If you want to go for the amazing candidate, then if you know something about NoSQL databases, so databases that are not organized in the type of linked tables, would also be very useful. Now, NLP. And NLP is something that we need to think about carefully. So NLP is extremely useful, and it's perhaps the area in data science in which there is most demand at the moment. Natural language processing / computational linguistics. However, I taught computational linguistics at UCSB for several years. And if I now came back, I would do totally different courses, really totally different courses. Because the field has dramatically changed in the last 3 years. So nowadays, of course, you need some familiarity with some libraries or frameworks, typically Spacey or the Stanford tools to do natural language processing efficiently and easily. But there is a huge move in the field to do everything using what are called transformers. Transformers are pre-trained neural networks that can be, with a little bit of additional training, have amazing results in many problems involving language. Now, as both a linguist and a psychologist, having spent a lot of time in my life learning all kinds of natural language processing tools, I feel a bit sad about this. So now much of the work that we have developed specific tools for is actually not that relevant if you have the option of doing things with BERT or with Roberta or with any of the many transformers that are now in the market. So transformers started being around in 2017, and now when I talk to people in industry, not only in my company we're still doing some old-fashioned natural language processing, but most people I talk to are only using transformers, which sometimes makes you think that why did I bother in learning all those additional algorithms and tools? What I find myself though is that if you really want to work in NLP today, you need to know transformers. And for instance, if you want a good tutorial, Hugging Face has just released a new natural language processing course. The first totally based on using their transformers. Hugging Face is a company that basically gives you access to transformers in an easy way. So if you Google a little bit, look for Hugging Face NLP course, and you might find a very nice introduction on how to use these things today. By the way, also a tip, I think I'm pretty sure that many people are beginning to use this also for academic purposes, but I can see all kinds of beautiful usages of these transformers for psycholinguistic purposes. So it's something that I would also recommend, not only for access to industry, but it would be useful that you start teaching it, because I think in a couple of years it will also be the standard in academia for any kind of NLP that you need to do for your research project. And finally, some basic knowledge of either TensorFlow or PyTorch. So TensorFlow and PyTorch, those who don't know, are libraries or frameworks with which to build deep neural network models. Now, for most jobs, you don't need to be a real expert in this, but just having played around with them a little bit, it's enough to land you a job, and then they will teach you on the spot. Unless you're going to be a machine learning researcher at Google or at Apple, in which then you have to be the master of TensorFlow or PyTorch at that before you even think of joining. But for most industry jobs, they'll give you a lot of leeway in the initial months, especially if they know you're coming from academia, they know what they're hiring, and they'll trust that you will learn, but you will have to learn, and some basic knowledge will be really important. So these are the technical skills, not much more than this. Now, as important as technical skills, there might be also some other collaborative tools that are really important in industry. So one thing that many people that I know complain about is that when you get people from academia, and that includes myself, by the way, that was exactly my situation, even if they're very good at programming and developing algorithms and solving problems, they work on their own notebook and create really, really dirty code that's very difficult to translate to other people. So tools for actually doing software engineering, things like GitHub at the moment is an absolute must. And I strongly encourage people to begin including that when teaching their courses in computational linguistics and programming. So typically we teach people how to solve the problem, but we don't teach people how to make that code usable by other people and how to maintain the versions of the code. This is something extremely important that I had to learn as soon as I landed in the industry. Then, especially those working in data engineering will have to do a lot of work using Jira. Jira is a tool for keeping track of tasks and how the tasks are progressing. Data scientists are also using it, but typically less intensely. And then very important, and this is the part that is, I would say, the more bullshit part of going into academia. So now there is different methodologies for developing software and for developing tools. The most popular by far are, and this come in many flavors, are what they call agile methodologies. Some of you may be familiar with them. Some of you might not. What I found is that most companies claim they are using agile methodologies. In most of the situations, what they are doing is they are using lingo from agile methodologies and not using the methodology at all. But what I would recommend, this is not so much, well, if you could get a course in agile methodologies, it would be amazing. But at least Google a little bit, a tutorial to get the basic terms so that if they ask you in an interview, you know what to talk about. And you can always be very frank, saying, look, I'm not an expert in agile methodologies. I know what they are and I know the basics. I know what a Scrum is, etc. But not much more than that. And very important, you need to be, if you're a data scientist in particular, not so much a data engineer, you'll have to present data very often. But you'll have to present data to audiences that are absolutely not technical and who will get completely lost with anything technical. So you have to, they'll trust you that the techniques is good, but they don't want to see the technical part. They want to see the conclusions in a very, very clear way. So being able to present technical data to non-technical people is a crucial skill. Not so much for your hiring, because they'll assume you have that, but for your progress as a data scientist or as a researcher outside academia. And that's about it. I hope this was not too trivial. I'm going to stop sharing screen and get back so I can actually see you. If I know how to do this. Stop share.
Well, thank you so much, Fermín. We're now just a couple minutes before 1 o'clock. Is it agreeable to you to potentially extend for a little bit of time?
Yes, no problem. No problem at all. I don't have anything after this, so.
Okay, great. Thank you so much. So anybody, if you have questions, you can either deliver your question orally by unmuting your mic, or you can let me know in the chat and I can read your question for you. Jordan has a question.
Hi, can you hear me?
Yes.
Great. First of all, thanks for an amazing talk. I didn't find any of that trivial at all. It was actually very eye-opening and very reassuring that the transition into industry can be smooth. My question is, if during the time when you were a PhD student, you had a crystal ball and you could see how your career was going to unfold, would there be anything that you would have done differently at that time?
Oof, that's a difficult question, because for instance, there is some areas in which I was doing research as a PhD, and I never pursued them in a kind of industrial way, that turned out to be extremely important things in industry later on. The only thing for instance, the whole issue with embeddings that's now so big, that was actually part of my PhD. What they call transformers now, I had the prototype of that in my actual PhD thesis, and I didn't follow it up. And then I found that people working on it seriously and from an industry point of view, and these people have made a lot of money. They're actually millionaires today. So it's like, that was a waste. But more frankly, what I would have done, I didn't actually ever look at industry. That's the thing. I only started looking at industry during the perhaps 2-3 years before I actually left academia. And what I would have done is keep an eye on what's happening in industry, how they are doing things, what kind of things they need, what kind of things they are doing. This is, keep an eye constantly from the very beginning. This would have, smoothed my transition and made me learn the kind of things that I needed to learn, and also give me, when there were good opportunities, there were very good opportunities in the late, around 2008, 2009, and I might have considered them by then. Not that I regret not having taken them, but what I regret is not having known about them. So even if you stay in academia, and don't get me wrong, as I said, I still miss many things about academia, and I still have enormous respect and liking for academia. So I'm by no means encouraging to leave academia if you don't want to. Although, as you know, it's a very competitive field and a tough field. But keep your options open, and by following up what's going on in industry, read blogs. I mean, I find that, for instance, there is a lot of stuff being published towards data science in Medium that I would really encourage you to follow, because that gives you an idea of what's happening in the industry, what kind of tools they are using. The industry is changing really fast. As I tell you, for instance, these transformers were first introduced in 2017. They now completely dominate the field of NLP in industry. So if you're going to go into NLP, basically they're saying, somebody was making a joke the other day, that transformer training has become a new job. So this means that you really have to keep on the bleeding edge, and the best way to keep on the bleeding edge is not scientific conferences or going to or reading journals, is literally the blogs. I find that the blogs in Medium, and in particular those towards data science, are extremely useful in giving you hints of what's going on. Does this help?
Yeah, great. Thank you for that. I appreciate it.
Okay, next there is a question from Laura. Laura, would you like to unmute yourself to deliver your question orally?
Yep, thank you. Hi, also thank you for the talk. That was absurdly useful. My question, sorry, my video is off. My question is related to so for my PhD project, I'm working with, I'm building a symbolic model, and I was wondering whether there's any kind of need for that kind of knowledge, or is it mostly neural networks now? Like,
well,
yeah,
actually, yes.
in industry.
There is a big, one of the areas that is actually coming up is what they call hybrid models. So models that are hybrid between a neural network and a symbolic model. So typically what you have is a neural network at one point, followed by something that translates that into a symbolic model. And also the whole field that I mentioned before of explainable AI explainable AI needs to be symbolic because you need to explain it to people. So yes, there is indeed a lot of value in symbolic models, and a lot of this you find is a bit like a pendulum. So it goes symbolic neural nets, symbolic neural nets in industry as well. So you really will need a knowledge of both. And if you ask me to play the prophet, I would say that in 5 years from now, we're going to see much more symbolic models going on, typically the hybrid type. So models that are on one end non-symbolic and on the other end symbolic.
Okay, thank you.
Okay, there is a question from Daniel Schmidtke. Daniel, would you like to unmute yourself to deliver your question orally? Okay, I will deliver his question for him. The question is, he says that this was very helpful. Is there a list of psycholinguistics and cognitive psycholinguistics that we could use to contact for help other than yourself?
Well, I don't know of a list. I know several of them, although I'm a bit hesitant to give their names public without their authorization to do so. But actually it might be a good idea to try to compile. So what I could do is give a few names to, for instance, to Victor, to one of you, and if you can contact them and see if they're happy to be put on a list. But I feel a bit uneasy about, I mean, I can give my own name for help, and I'm happy that if people contact me for help, but I'm not so confident of giving other people's names without their permission. But what I can do is give those names, say, in confidence to Victor, and Victor or anybody else who might take charge of this, and you might contact them and create this list with their authorization to be put in the list. Does this make sense?
Great. Yeah, I'm happy to mediate.
That's great. Okay, there is another question from Javier. Would you like to unmute yourself?
Sure. Hi, first, thanks for your talk. I want to know how easy or how how definite is this movement to the industry if you then would like to go back to the academy?
Okay, so this is actually a very important question, and it's something I should have talked about. There was a time not so long ago when if you moved from academia to industry, there was no way back. Fortunately, that has changed. That means a few years ago, this was impossible. Nowadays, there is much more permeability from one to the other. Among other things, I think many departments are beginning to see a value in the experience you gain in industry, especially bearing in mind that the academic job market is completely rotten at the moment. By completely rotten, I mean there's too few jobs for too many people, and the competition is enormous, and especially once you have a family and things like that, you cannot afford to be moving countries every year from postdoc to postdoc. So they want to also give students the possibility, specifically in linguistics and psychology, which have been, especially experimental psychology, have been traditionally academically oriented fields. I think there is, people are beginning to appreciate that in people with experience in industry might bring students, might open students other avenues. Having said this, it's important that, well, during your time if you move to industry, most jobs nowadays allow you for publishing in conferences and even journals. So I have, for instance, during my time in industry, I've been 3 years here and I published a few papers still. Mostly related to, I mean, there is limitations in what you can publish and not through intellectual property, but you can still keep active. I've also been part of a PhD committee, for instance. So if you keep some touch with the academic community, it is possible to go back if you want to. Now, having said that, if it's difficult to find a job for people who are within the academic community, it will be a bit more difficult if you're coming from outside. But it's certainly possible nowadays. And for instance, Marco Baroni has just done the transition from Facebook into the university.
Yeah, thanks. I think that answers my question.
Okay, there's one more here from Adriana.
Hi, Fermín. Thank you for this really wonderful and very helpful talk. it was not trivial at all, but I might have a trivial question actually. So my students are always telling me, well, why do you want me to stay in academia? I kind of like stability, and industry might give that to me. Is it true that if you work in industry, you have a stable contract and you don't take work home, let's say after 4 o'clock or 5? Is it true, or is it just a myth?
Well, stability nowadays is becoming a luxury in all areas, both in the academic world and in the industry world. Specifically, if you are working, for instance, in a startup, startups don't know how long they're going to be alive. They might be a successful startup, or they might die next year. So you always have the possibility of changing jobs. What you do have, for instance, is typically higher salaries in academia. Specifically, data scientist jobs are very well paid today, very, very well paid. In particular in the Americas, less so in Europe, but even in Europe, the salaries are good. And the fact is, in academia, finding a next job will be difficult. So although in industry, you know, you can always lose your job, you know that you're going to be very fast at finding a new one. So that's not so much of a problem. So there's not more stability because there is less likelihood that you will be fired or you will find a longer job. There's more stability because it's easier to find another job than it is in academia. Does this answer your question, Adriana?
Wonderful. Yes, thank you.
Oh, forgot to mention, and about the schedules, that is true. So in academia, you have weekends. In industry, you have weekends, and weekends are actually weekends. So I stop reading my mail on Friday, and I don't open it again until Monday.
That sounds fantastic.
Okay, so there are no other questions on the chat at this time. Thank you so much, Fermín, for your presentation. If anyone has any other questions, I'm sure feel free to contact the Words in the World grant and we will forward questions to you. Is that acceptable?
Perfectly so. And also say, as I said before, if any of you is doing that transition and needs some help, I'll be happy to feel free to contact me. A lot of people help me, so.
Wonderful. Thank you so much. Okay, with that, I will close our session today. I hope you all enjoyed it as I did. The talk will be made available, the recorded talk will be made available on our website, and that'll be included in a future email update about open office hours. So keep an eye on that. If you have colleagues that aren't yet receiving updates, please do encourage them to sign up. And Victor, sorry,
just before you end the session, first of all, Fermín, fantastic. Thank you so much. It's not trivial and immensely useful. I'm already foreseeing my students asking me to now teach them or learn with them all the tools that you mentioned that we might not have an idea about, but this is only to our benefit. And another thing that I wanted to say to this audience is that we will be taking a summer break with the open office hours, and we will be back in September with a new lineup of people from different areas.
Well, thank you very much for having me here. It's a pleasure to talk to you guys. And well, bye-bye.
What a treat. For me, thank you so much.
Take care.